Code is not executed directly. It goes through at least 4 more intermediate steps. First, the C code is compiled into a series of instructions, or machine code. This machine code is stored in the microcontroller chip. During execution, the machine code is loaded into registers inside the CPU. Then, based on the contents of the registers, the CPU controls the respective pin. That will switch the LED.
Why do we have to convert C code into a series of machine instructions? Because a microcontroller cannot understand a single word of your code. It is like you're trying to communicate with a foreigner who does not understand your language. In such a case, we will get the help of a person who understands both languages. We usually call such a person as translator. We have to do the same action to make your C code understandable to the microcontroller. We can do this by a computer program, which is called compiler. The compiler not only do the translation, but also check the errors in the code written by you. Now let us have a look at machine instructions. It is nothing more than a bit sequence of zeros and ones. We have different types of instructions, and each instruction is associated with a unique bit pattern. In order to make the machine instructions understandable to us, each bit pattern is also associated with a text label. For example, label out is associated with an instruction which writes data in a register to an output. This slide contains 5 such labels: LDS, out, and, RJMP, and NOP. As a beginner, I do not recommend you to study more details of machine instructions at this early stage. It is enough to know that your code is converted to machine instructions by the compiler. These machine instructions go through 3 steps while your program is executed by the CPU. These 3 steps are called fetch, decode, and execute. Fetch means you get the instruction from the program memory. Decode means analyze the instruction and determine the actions to do. Execute means do the actions requested in the instruction. This process is very similar to your mom preparing a nice dish by looking at a recipe book. Read the recipe, decide what to do, then prepare the dish step by step. Okay, now let's have a look at the details of the CPU. It is a tiny but powerful electronic circuit. It fetch, decode, and executes instructions as explained in the previous slide. Therefore, we can say that it thinks, decides, and controls everything inside the chip. Remember, it runs your program instruction by instruction very fast. Based on the instructions, it manages the data flow between memory, registers, and pins. Inside the CPU, you find units such as program memory, flash, data memory, RAM, I/O ports or pins, registers, timers, and so on. Then let us have a look at registers. They are super fast storage locations inside the CPU. Note that reading data from flash or RAM is very slow compared to reading data from a register. That is why we say registers are super fast. Registers are used to hold data, addresses, results, instructions, flags, and many more. We have come across 2 new words, addresses and flags. Addresses identify memory locations, and flags represent special conditions happening during calculations. We do calculations inside the CPU. We use registers to get input data and to store results.
What is a pin? They are small metal connections visible on the sides of a microcontroller. Each pin has a specific job assigned to it. Some pins are dedicated to provide power to the CPU. You get 5-volt, 3.3-volt, and ground pins. You have input and output, I/O pins. Under the control of your program, you can configure I/O pins as inputs or outputs. Furthermore, there are some special function pins such as UART, I2C, SPI, PWM, analog, and so on. At this stage, do not worry about these special function pins. If you look at the photographs of an Arduino board, you can identify such pins. I think now you have better idea about how your code switched on the LED. Based on the C code you wrote, compiler generated the machine instructions and stored in the flash memory. When you execute the program, CPU read the flash memory sequentially at very high speed and loaded each machine instruction one by one into its internal registers. This is instruction fetching.
Then the instruction was analyzed during the decode stage. Then content of the internal registers were directed to the respective pin, turning the LED on during execute stage.
I think now it is good to take a break and watch this.
When you were a child, someone may have asked, "Can you draw a house?" You drew a roof, a door, and windows. No one taught you architecture, yet you knew what a house was. Before you drew the house, something happened inside your mind. You had seen many houses. It created a mental model in your brain. And then you drew that model on paper. The same thing happened with bicycles, trees, cars, animals, people. As children, we were constantly building mental models of the world around us. As we grew older, school taught us many important things: mathematics, science. But often, we spent less time building our own explanations of how things worked. Suppose you want to understand how a car engine works. You can use a model. You can watch the pistons move. You can see the crankshaft rotate, observe how the parts work together. But what about a microcontroller? Can you see the processor? Can you see the registers? Can you watch instructions execute? Can you see information moving inside the chip? No. Everything is hidden. Mechanical systems often come with models that help us understand them. Microcontrollers usually do not. That creates a challenge. How do we understand something we cannot see? The answer is the same skill you used as a child. Observe. Imagine. Build a mental model. When no physical model exists, you create one inside your mind.
Is it easy for you to understand what is happening inside the microcontroller? Is it easy for you to remember what is happening inside the microcontroller? There is a very effective way to do that. I am going to tell that secret. Make a movie. Yes, make a movie. Okay, let us close our eyes and imagine. Scene 1. Imagine your PC converts your C program into a bit stream. Send that bit stream into your microcontroller. Microcontroller records this bit stream inside its flash memory. Next, Scene 2. A counter inside the CPU is showing value 0. CPU asking the flash memory to read the bit pattern stored at the bin number 0. Scene 3. CPU asking flash to send the data in bin 0. CPU stores the sent data inside a CPU register. Scene 4. CPU analyze the bit pattern just read from the flash. CPU understand what to do next. Scene 5. Imagine there is a special register inside the CPU controlling the pin connected to your LED. Now the CPU immediately changes the value of that register. Next, Scene 6. The pin connected to the LED gets a high value. The LED is switched on. Open your eyes now. Now I am going to tell you another secret. Close your eyes again. Run the movie over and over again in your mind until you understand and remember well. Let us run the movie. The program is sent to the flash memory. The program counter points to a bin in the flash. The CPU fetches it. The CPU decodes it. A special register inside the CPU changes. Pin 13 becomes high. The LED turns on. Let us run the movie again. The program is sent to the flash memory. The program counter points to a bin in the flash. The CPU fetches it. The CPU decodes it. A special register inside the CPU changes. Pin 13 becomes high. The LED turns on.